What's up, everybody? All you remote learners out there, I want to take you through this classroom experiment. When I explain this, you can go ahead and do this on your own if you've got a thermometer at home, but you could also use the data that I present to you today. You could add this data by pausing the video into your Science Notebook page. So if we look here at Sci-Hub, we're currently learning about natural disasters. And in order to understand natural disasters, we have to understand weather, because a natural disaster is just an event where the weather situation has become so severe and so intense that it's overwhelmed the human capability of responding to it and recovering from it. So in order to understand these natural disasters, we must understand weather. So let's enter the blue square. In the blue square, we're going to be using this guiding question of how do the properties of air impact weather? So we're going to be learning about weather and how air, different types of air and the properties of the air give us different weather. So the learning target is to investigate how air temperature and pressure and the differences between different air temperatures and different pressures impact local weather. All right, so we're on the Heat the Beach experiment here. If we go to the procedure, let's take a look at what we need to do. So this experiment is designed so that we can investigate our guiding question of the unit and to approach our learning target, but even this experiment has its own guiding question. So in this experiment, Heat the Beach, we're going to look at how solar energy affects the temperature of different surfaces commonly found on Earth. So I say heat the beach because a beach is an area where the land meets the water. And if we look at the planet Earth, 2/3 of our planet, so about 66%, is water, and the other 33%, the other third of our planet, is going to be land. So since most of our Earth is either land or water, we're going to look at how the sun hitting the land and the water have different impacts. All right, so we had a bin of dirt, and that bin of dirt represents land, and the bin of salt water represents oceans. We actually didn't add salt, but we just have a bin of water to represent oceans. So maybe I'll even just delete that part. Okay, we have a glass thermometer to measure the temperatures, and we're using lamps to represent the sun. All right, so to begin with, I had everyone set this up the same way, where they got the land and the water, they put them next to each other, turned on the lamp, and then put the lamp over those two bins so that they're heating each surface equally. And every minute for 5 minutes, they use a glass thermometer to measure the surface temperature of each material. They recorded their information in their science notebook, and then after 5 minutes, they go on to do a second sample, which I'll talk about at the end. I think it's going to be easier to understand as a summary here for me to just explain that one of them is a day sample. So what we did here is we turned on the light and we let it shine. And so we watched to see what happened to the water and the land and how the temperature changed as the sun was on it for longer and longer and longer to see which one is heating up faster. So let's look at those results. So if we take a look here, this first picture is a infrared, this infrared device here that I can use to look at the heat signature. So we can see that we've got the land and the water in the bins that are right there next to each other. And since they're right there next to each other, the light is hitting them equally. But if we look at the infrared signature of these, you can see that the land is getting much hotter than the ocean is. So if we look at those surfaces even, the dark surface is going to absorb more heat than this clear surface, which is the water. And this might even reflect some heat actually. But when we look at the data tells us the same exact thing. At first, when we measured the temperature of the land and the water, it was 66 and 72. Now the ocean didn't change. The water didn't change temperature at all. It takes a lot of heat to change the temperature of water actually. So we had 72 for the whole time. Now with land, the land actually cooled down. And most likely what happened here is some type of error, and maybe we should have started, or maybe the reading was actually 62 to begin with. This is data that I got from a group that was in class. So if we look at this data for the land, let's say it started at 62, and after 13 minutes, it increased to 74 degrees Fahrenheit. So if we look at our next slide, we can look at why this matters. So with the day sample, we started with 62, it ended at 74, The ocean stayed at 72. The time elapsed was 13 minutes. Over 13 minutes, this happened. Over 13 minutes, the land heated up by 12 degrees, and over 13 minutes, the ocean cooled down or heated up at 0. All right. Well, we also did the same experiment, but we did a version where we looked at, well, what would happen at night? So what I did was I turned off the lamp when students arrived to class. So I had the lamp running from the last class. I took one of the group's demos. I left the light on for their demonstration after they turned it off for the day sample. I turned the light back on. So those two materials started out warm because they had been underneath the sun or the lamp. Once the students arrived, I turned the lamp off and I recorded the time. And then throughout their experiment, when they're in the middle of their experiment, I had them go ahead and take a look at what the night temperature was. So when I first turned off the lamp, I measured the temperatures because that would be the end of the day. That's like sunset. I turned off the lamp. So at sunset, the land was 82 and the ocean was 66. Then after 43 minutes, this group measured the temperature of the land and it had cooled down to 60. We measured the temperature of the water and the water was still 66. So what this means is that the overall change in temperature over 43 minutes as the land cooled down, it went down 22 degrees Fahrenheit. The ocean water did not change. Now, in real life, the sun is risen and night lasts more than 43 minutes or more than 13 minutes. So usually there is some change in the ocean temperature, but not just in one day. If you think about like swimming in Horsetooth Reservoir, it can get warm in Horsetooth Reservoir, but it takes all summer. It takes that daily heating process to slowly raise the temperature of the water. It takes a lot to heat up water. So now that you have this information and you can use this data as I've presented here in my science notebook pages that I got from a group from yesterday, you can use this data to insert this into your science notebook. And hopefully the explanation in the videos that I've shared now with you today will help you also be able to complete the conclusion questions once it's time for you to complete the conclusion questions. So if you do have questions about this experiment or you have any interesting observations, I'd be happy to hear those. I'd love to hear from y'all, especially those of you that are remote learners. So holler at me if I can be of any assistance or if you have any questions at all, or if you just want to chat, shoot me a message on Microsoft Teams. I'd be happy to chat with you. All right, y'all, have a great day, and I'll see you next time. All right, lastly is that if I went a little too fast for you there, I'm going to add some screenshots right now of the data. So go ahead and record this data, or go ahead and do it yourself. See if you can get similar data using a thermometer, some type of heat source to heat up the land and the ocean, or just use the data that I'm providing here from some of your peers in class. All right, y'all. Deuces.